All right, so number 1A, the calculator question. They give us a chart, R in centimeters, F of R in milligrams per square centimeter, the density of bacteria in a petri dish, a circular petri dish. And let's see. First thing they want us to figure out is an approximation for F prime of 2.25. So this is very similar to many of the other problems we've done, where you just need to take the values in the chart and find the average rate of change on the interval that surrounds 2.25. So we will do 10 minus 6 over 2.5 minus 2. You'll get 4 over a half, or 8. Using correct units, interpret the meaning of your answer. So if we are taking the derivative of something that is milligrams per square centimeter, what should our units be? So yeah, except you gotta sort of say it because it's already in milligrams per square centimeter, right? So milligrams per square centimeter per square centimeter would make more sense then. We're taking the derivative with respect to R, so it should be milligrams per square centimeter per centimeter. So this is milligrams per centimeter squared per centimeter. Does that make sense? Yeah, since the R is in centimeters. The 4 is milligrams per square centimeter. The 0.5 is centimeters, milligrams per square centimeter per centimeter. Or you could say milligrams per centimeter cubed if you wanted to. That'd be fine also. And so we want to interpret the meaning of this. So what is the meaning of this? This is the rate of change of the milligrams per square centimeter. The milligrams per square centimeter is representative of the density. So we would say that the density we would say that the value, you could say however you want. So the density or the value of F of R is increasing at a rate of 8 or something like that. You'd say that the density is increasing at a rate of 8. That's probably good. At a rate of this. Yeah. Did you get both those points, Leopold? All right. I'm going to ask you for every single question. You're gonna really enjoy this. Everybody good with A? Everyone's good with that. Part B, the total mass is given by this integral, 2 pi times the integral from 0 to 4 of R, F of R. We want to use a right Riemann sum with 4 subintervals to approximate this integral. Okay? So that ought to be 2 pi times, and then if we're integrating R times F of R, well, we need to find the value of R times F of R at each of these intervals. And we're doing a right Riemann sum, so we're first going to do 4 to 2.5. So from 4 to 2.5, what's the distance there for the length of that subinterval? Should be 1.5, right? And what is R times F of R when R is 4? That's 4 times 18, right? Which is 72. And then we will add to that the next value. So if we're going from 2.5 to 2, that's going to be 0.5, right? And R times F of R is going to be 25. 2.5 times 10. And then 2 to 1 is 1 unit. And R times F of R is 12. And then 1 to 0 is 1 unit. And R times F of R is 2. And you have a calculator? And what did that come out to be on your calculator? Didn't you guys all do this yesterday? Oh, you missed that R in there. Yeah. Bummer. You get it? Anybody get an answer? Answer? Did it wrong?
845.884.
845.884. Anybody agree with that?
I got 845.088.
845.088. Serena's also nodding her head to that.
It's 884, but 0884. So I just forgot the 0.
Yeah, don't forget that 0. That'd be unfortunate. Cool. Everybody go with that? You could leave it in pi if you want, but it doesn't really matter. Normally, like on the scoring guidelines, they have the full answer written out when it's a calculator problem. But they'd accept either one. Everybody good with part B? Okay. Part C, is that approximation an overestimate or an underestimate? So what? Why is it an overestimate? Right, we did a right Riemann sum. F of R is increasing. It says it is an increasing function. Right, just because these values are increasing doesn't mean that it's an increasing. It's only an increasing function. Right, they could be going down in here or something, but it says that it's increasing, so we know it's increasing. Also, R is getting bigger, so we would say that F of R is increasing because, like I said, F of R is getting bigger and R is getting bigger. You multiply those together, that's getting bigger. So the function that we're integrating is increasing. So a right rectangular approximation is an overestimate. Everybody go with that? Remember that for an increasing function, the right is an overestimate, the left is an underestimate. You can always draw it out if you need to. Right? Clearly, those are going to go over. Yeah. No, they want if it says explain your reasoning, they want words. Yeah. Not just a picture. Yeah. But I mean, what I wrote there would be enough. So it's not like you got to write a lot. Any other questions there on that part? People in the Zoom, the few people that are in the Zoom today. Why are there so few people in the Zoom today? Is there an AP test today? I mean, I know there is, but which one? AP what? Oh, that's you. I can never tell who's talking. AP Lang. That's a junior English class, right? Yeah. All right. Part D. The density of bacteria in the dish for 1 to 4 is modeled by the function g, which is this thing. We want to know for what value of k on 1 to 4 is g of k equal to the average value. Well, if you want to figure out when g of k is equal to the average value of g, you need to find the average value of g. Right? You can't figure out when something's equal to the average value if you don't know what the average value is. So let's find the average value of g. How do we do that from 1 to 4? Should be 1 over b minus a times the integral from a to b of g. You have a calculator, your calculator will tell you that value. What is that value?
9.876.
9.876. Everybody agree with that? Anybody agree with that? Leopold, you got 9.876? You don't remember? 9.876? Anybody?
Yeah,
that's what you got. Okay, all right. So then we can just set that value, 9.876, equal to g of k. We want to know when is g equal to the average value of g. So set 9.876 equal to 2.2 minus, what was it? 2 minus 16 cosine of 1.57 square root r. Fun. Cubed. Is that there? Cubed? Cubed. So just set those equal to each other and see where they intersect. If I were you, if I was doing this on the AP test, I would set my calculator's window for x values to go from 1 to 4. Right? Just go hit window on your graphing calculator and change the x min to 1, the x max to 4, and then that'll give you a better window to look at. Get some value for r. What is that value? Now what do they want? They want it to be g of k, so we'll make this a k. Just for the correctness of the variables that they gave us. K. Anybody got an answer?
2.497.
2.497. That sound good to other people? Yeah? Yeah. All right. Any questions on that first one? All you people over there furiously punching your calculator, is that what you guys got? You all right with that, Riley? No? You what? Oh, you could finish if you want. I mean, you don't have to. That all looks really familiar, right? Those are all the answers you got for sure. Yeah. That's good. Good. Good work. We're just gonna pretend you got everything 100% right as we go through. That way I'll feel better about myself. And know you were prepared. All right, everybody good then? Next one. Did you finish typing it in? Oh, did you want to? Okay. But you know how to type it in. Okay. All right. Good. Okay. You seem like you're awfully embarrassed by the fact that I keep calling you out. Okay. This is fun. I'm enjoying this. This is just getting more and more awkward. This is great. Are you enjoying this? This is fun. Yeah. Yeah. It's good. Okay. All right. Everybody at home, you ready for this one?
Yeah.
Okay. All right. So we got a particle P is moving along the x-axis, so we're given its velocity. And then we've got another particle Q, and it's moving along the x-axis, and we're given its velocity. And we're also given positions for both of them at t equals 0. First thing we need to do is find the positions of both of the particles at t equals 1. So the position of P at 1 ought to be its position at 0, right? Plus the integral from 0 to 1 of the velocity of P. Everybody good with that as the setup? This one is like, I mean, very, 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 very similar to all of the particle motion ones that we did, right? What did that come out to be for the position of particle P? 5.371. People agree with that? Yeah. Nice job, Riley. Good work. Yeah, that's excellent. All right. And then what about for a particle Q? That should be the position of Q at 0 plus the integral from 0 to 1 of the velocity of Q. And what did that come out to be? 8.564. We agree with that? Yeah. Oh, lots of agreement here. 8.564. All right. My guess is that might have been worth 4 points. Really, I don't know. I'm just usually it's like a point for remembering the initial condition. It might have been 3. Probably a point for remembering both initial conditions and then a point for the final answers, or 2 points for the final answers. Or A point for the integral, a point for the integral, and a point for the two answers. Probably worth 3 points. That's fine. That's my best guess. That's what you got for all those, right? You remember those? Yeah. Perfect. Yeah. Good. All right. Part B. Are they moving toward each other or away from each other at time t equals 1? Okay. Well, in order to figure out if they're moving toward each other or away from each other, we need to know which direction they're moving. So we need to figure out v sub p at 1 and v sub q at 1. So v sub p at 1 is equal to what? What's that? Do you have an answer? No? Okay. Oh, you definitely don't have an answer. No, certainly not. How are you? I'm doing great. Oh, you still go to school here? Yeah. How are you? I'm great. What can I do for you? Are you just here to say hello? So he sent you to me. Mr. Selby sent you to me for graph paper. Do you think that I have graph paper? One second here, people in the Zoom. What was v sub p of 1? 0.841. People agree with that? So this is moving to the right. Okay. And then what was v sub q of 1? -1. So now it's moving to the left. And so they want to know if they're moving towards each other or away from each other at t equals 1. So we look and we say, well, at t equals 1, here's p, here's q. This is like 5 point whatever, and q was 8 point whatever, right? P is moving to the right, q is moving to the left, so they must be moving towards each other. And so you'd want to say they're moving towards each other because P is to the left of Q and moving to the right, and Q is to the right and moving to the left. Right? Something like that. Make sense? That's what you got on the AP test, right? Perfect. Good. You're learning. You just say yes, and then I don't bother you about it anymore. Good. No questions on that? People in Zoom, you good with that? I mean, I know you guys would rather talk about the weather, but we're good? All right, part C. Find the acceleration of q at t equals 1. So acceleration of q at 1 is just v prime of q at 1, and your calculator will figure out that value for you. What's the derivative of v sub q at 1? People agree with that? Yeah? Okay. And then we had to look at the velocity of q at 1, which we already determined was that the one that was -1? Okay. And so if the acceleration is positive, but the velocity is negative, then the speed must be decreasing, and the reasoning would be v and a have opposite signs. Easy enough? Yeah, everybody good there? Wonderful. And was it part D? Yeah, that was part D. Find the total distance traveled by particle P from 0 to pi. So total distance traveled is an integral of the speed. So for part D, we're going to integrate the absolute value of the velocity of, what was the particle? Was it P or Q? P. So V sub P of T, dt. And it was from 0 to pi. So from 0 to pi. And what did that come out to be? 1.931-ish. Yeah. Everybody's good with that? That's what you got for all those, Leopold? No, the answer is yes. Yes. Yes, I did. Yes. There you go. Yeah. Hopefully you did. But that one I think was pretty straightforward, especially after looking at all of the particle motion ones that we have done in class. I hope. Seems like a lot of people were in agreement about the answers to it, at least right off the bat. So that's good. You did, Akash? You got them all right? That's good. Okay. All right. And then this was their little area volume problem that they threw on this year. A little bit different than some of the other ones that we looked at. They kind of put like a sort of an application to it. I had a couple people that told me they didn't like this one that took the test on the 4th, but I don't know. I don't think it's not that bad. You didn't like this one? Leopold didn't like it. Yeah, nobody. I don't know. A couple people came by and were like, "Can you show me how to do this one?" I don't like it. So we got this spinning toy company. They're using the family of functions y equals cx root 4 minus x squared, where c is just some positive constant. And so that's the graph of cx times square root of 4 minus x squared for some c. And they're saying that these spinning toys that they're creating are just in the shape of this solid when it's rotated around the x-axis. So the first thing they want us to do is find the area of the region in the first quadrant, bounded by the x-axis and the graph of this y equals cx root 4 minus x squared when c is 6. So if we're just looking for the area, all we need to do is integrate from 0 to whatever this x-intercept is. Yeah. When c is 6. So this will be 6x root 4 minus x squared. And where does this intersect here? When does 6x root 4 minus x squared equals 0? Because now we don't have a calculator, right? We got to figure this out on our own. That's whenever 6x equals 0, so that'd be if x is 0. Or if x is 2. And if x is 2, that's going to also be 0. Everybody agree with that? So the area should just be the integral from 0 to 2 of this function. Everybody's good with that being the basic setup for part A? How do we integrate 6x root 4 minus x squared? Let u equal 4 minus x squared. Du will be negative 2x dx. So I'm going to need a negative, which means I'm going to need another negative. I'll put a negative in here. And now I've got, let's see here. I'm using 2x of this 6x to get my du. So what's left? 3. So we got negative 3 times an integral of u to the 1/2 du. And then our lower limit needs to change. What does our lower limit become? Got to plug in 0 to u. So that should become 4. And then I need to plug in 2 to u, which gives me 0 for my upper limit. And so what are we probably going to do then? Just flip the integral. Make this 3 times the integral from 0 to 4 of u to the 1/2, which ought to become what? 3 times 2/3 u to the 3/2 from 0 to 4. Plug in 0 to that and it's just 0, right? So we can ignore that. Plug in the 4. Square root of 4 is 2. 2 cubed is 8. That's 16 thirds times 3, which ought to just be 16. And they gave us units of inches. They didn't say anything about units, so you don't need to put the units, but it's 16 inches squared. Everybody good there with part A? You got 16 inches squared on the test? What? No? No, I thought you were supposed to say yes. Oh, no. All right, well, that's right. You got all the other ones right. Yeah, part of it's better than none of it. Yeah, make sure you remember to switch your limits of integration. That's important. Yeah. All right, part B. It is known that for y equals cx root 4 minus x squared, dy dx is this thing. The radius of the largest cross-sectional circular slice is 1.2 inches. What is the value of c for the particular one that has that largest cross-sectional circular slice of 1.2 inches? Okay, so how do we go about this one? What do we do? We got the function, we got the derivative. Right. we need to figure out when our derivative is equal to 0 because that's when we're going to be at this local max. And that's when we're going to be having our largest cross-sectional slice, right? So when does this derivative, when does dy dx equal 0? Well, that is when, just deleted that page. That would be when c times 4 minus 2x squared is equal to 0. So we'll have c times 4 minus 2x squared is equal to 0. Sorry, c times 4 minus 2x squared. Yep. So what value makes that true? What value of x makes that true? When x is square root 2, positive or negative square root 2, but we're talking really only positive. So we know that it's at a max when x is equal to the square root of 2. And we want to figure out, it says that the radius, that largest distance up there is 1.2 inches. So we need to figure out what c is when x is the square root of 2. So we're going to take cx root 4 minus x squared, set it equal to 1.2 when x is root 2. So we have c root 2 square root of 4 minus root 2 squared equals 1.2. Does that make sense, everyone? Everyone good or no? Yeah? Yeah? No. All right. We got the square root of 2 squared is 2. 4 minus 2 is 2. So we end up with c root 2 equals 1.2. Well, root 2 times root 2 is 2. So that would be c equals 0.6. Everybody good with that? Good? Okay. Everyone's good? Austin, you good with that? Yeah. Ryan, you good with that? Zoom, you good with that?
Yeah.
Great. All right, and then part D, for another spinning toy, the volume is 2 pi. We want to find the value of C for that. So how are we going to do that? Volume ought to be pi times that radius squared. What is the radius? Just that y value, right? So the volume ought to be pi times the integral from 0 to 2 of our function c, what was it? Cx root 4 minus x squared dx. And we want the volume to be 2 pi. So first off, we can get rid of the pi's, right? We end up with the integral from 0 to 2 of, well, what does this become then? This becomes c squared x squared times 4 minus x squared equals 2. And so we're just looking for the c value that makes that true. We'll have to distribute all this out to do this integral. We have integral from 0 to 2. And in fact, we could, c squared is just a constant, right? So we could just take that constant out if we want to. C squared integral 0 to 2, 4x squared minus x to the 4th is 2. And we'll end up with c squared times 4/3 x cubed minus x to the 5th over 5 from 0 to 2 equals 2. And then what? Plug in your 2, plug in your 0. So we've got c squared times, what is that? 32 thirds minus 32 fifths equals 2. And what does that give us here? t squared, what's 32 thirds minus 32 fifths? 64/15 sounds good to me. And so we'll have 30 over 64. Or C is equal to root 30 over 8. Good or no? Good? Is that what you guys all got? 1, 2, 3. Everybody okay with that or no? Make sense? Yeah? Okay. Cool. So we will do the other 3. I haven't even, what are the other? Graph one and a differential equation. 2 different differential equation ones? Oh, it's not a differential equation. That's just one of the random ones. That's a nice easy one. And a differential equation. Yeah, so we'll do those 3 tomorrow. Let's do a couple of rate problems now then. Yeah. Get ourselves right. What rate problems did I already ask you guys to do? 4 and 5? Water being pumped into the tank right here. I don't think they can see it. No, that's not the one I wanted. There we go. This one. So we are estimating R prime of 2. So this is just like the first part of that first one that we did today. Estimating R prime of 2 ought to just be 950 minus 1190 over 3 minus 1. Everybody go with that? What does that come out to be? That's what, negative 240 over 2, negative 120. Units of measure, let's see here. What do we got? We got liters per hour squared. Looks like liters per hour per hour. Everybody go with part A? Yeah. Use a left Riemann sum with 4 subintervals to estimate the total amount of water removed. So we're going to, let's see, during the 8 hours. So if we're going to use a left Riemann sum, that means we're going to start at 0, use the height at 0, which is 1340, and multiply that by the width of that interval of 1. And then add the next one. Next one should be what? 1190 times, should be 1190 times what? 2. And then the next one should be 950 times 3. And then the last one should be 740 times 2. And I don't know, what does that come out to be if you add all that together? You don't know. Somebody knows. What does that come out to be if you add those together? Guess I could pull up how the scoring guidelines are. Didn't you guys already do this one? This is the one you were supposed to do, right?
8,050.
8,050. People agree with that? No? Yes? Anybody agree with that?
Yes.
Oh, wonderful. Okay. Second part of part B is this an over or an underestimate? Well, this function is a decreasing function. A left Riemann sum on a decreasing function will overestimate. So you would write that it is an overestimate because R of t is decreasing, and it's a left Riemann sum. Everybody get that? According to the scoring guidelines, 8,050 is right. Wonderful. First problem was actually worth 2 points, one for the estimate and one for the units. This one was worth 3 points. One for setting it up correctly, one for the value, and one for your explanation as to why it's an overestimate. Everybody good there with A and B? Any questions on A and B? Okay. All right, part C, we want to find an estimate of the total amount of water in the tank to the nearest liter at the end of 8 hours. So, the total water in the tank ought to be the initial amount minus the amount of water that leaves plus the amount of water that enters, because there's water entering also, right? Yeah. It's pumped into the tank at W of t. It's leaving the tank at R of t. Right? So how much did we have initially? $50,000. I don't know what keeps happening to this. I lost my whole page. There we go. Okay. 50,000 minus the amount that leaves, which we said was 8,050. And how much water enters the tank from 0 to 8? The integral of this. And that should have come out to be 49,786 liters. And I think it must have said, yeah, to the nearest liter. Everybody good there? 1 point for the integral, 1 point for the answer. Everyone good there? All right. Then part D, we want to know, is there a time when the rate at which water pumped into the tank is the same as the rate at which water is removed from the tank? So how would we go about that one? How do we go about that? Any thoughts on that? Anybody in the Zoom? The people here are staring at the screen, trying to avoid eye contact with me. People in the Zoom? Any ideas? People here, any ideas? How do we do this part? How do we do part D?
You take the estimate and the integral that we found and see which one is greater.
Take the estimate and the integral we found and see which one is greater.
Because the estimate is like the amount that is gets into the tank over 8 hours, and then the integral that we found is the amount that is left the tank in 8 hours.
I don't think that's going to do it. We're specifically talking about the rates for both of them, not like the amount of water that goes in. Let's think about what is the rate of change of water in the tank equal to? Not the amount going in, not the amount leaving, but what is the rate of change of the water in the tank equal to? Should be the amount pumped in minus the amount pumped out. Should be W of T minus R of T. Well, in order for the rate of change of water in the tank, in order for the rate at which it's pumped in and the rate at which it's pumped out to be the same, that would mean that R minus W would need to equal 0. Right? What did you say? Oh, sorry, W minus whatever I wrote there. W minus R. We need W minus R to equal 0. Right? Well, it's hard for us to figure out if that's ever true because we're not actually given a function for R. We're just given selected values of it. But we could determine potentially that W minus R at some point was positive and W minus R at some point was negative. And if W minus R was positive at some point and then it was negative later on, then we know that, or vice versa, then we would know that sometime in between there, because they're both continuous functions, that it must have been 0 by the intermediate value. Everybody good with that? So we'll just have to test some values. Let's look at what's going on at 0. So let's say, what is W of 0 minus R of 0? W of 0 is W of 0 is 2000, right? Because this is 2000 e to the 0. So W is 2000 and R is 1340. So that is positive at 0. So if we can find a place anytime after that where that rate of change is negative, then by the intermediate value theorem, it must have been 0 somewhere on that end. So I don't know. It doesn't really matter what we try. I mean, we got to try one that works, but probably, I don't know. What do you guys want to try? 1, 3, 6, 8? All right, 8 it is. Let's try that. So W of 8 minus R of 8 is what? W of 8 ought to be e to the negative 64/20 times 2000, whatever that is. It's what? 81. 81.524-ish minus 700. Is that positive or negative? Negative. So yes, by the IVT. And you need to write a little more. You'd be like, okay, so the rate of change. I mean, basically, if you wrote what I wrote, you're probably good. Okay. The rate of change is W minus R. W minus R equals 0. What we're trying to find. W of 0 minus R of 0 is positive. W of 8 minus R of 8 was negative. Yes, by the IVT because W minus R is continuous. Yeah, if you write IVT, that's fine. Everybody good with that? So I feel like that one was pretty easy up until part D, maybe. Part D had to put a little more thought into it. Or wait for me to answer it for you. One of the two. People in the Zoom, are you guys good? Do you have any questions? You're awfully quiet today. All right. The rate at which rainwater flows into a drain pipe. That's the other one I asked you guys to do. Yeah. Yes, no, maybe, yeah. What's part A going to be? What do we do? We want to know how many cubic feet flow into it during the 8-hour time period, 0 to 8. Well, that ought to be an integral from 0 to 8 of R of t. And what did that come out to be? Anybody?
$76.570.
Wonderful. That was worth 2 points. 1 for the integral, 1 for the answer. Everyone good with that? Part B, is the amount of water in the pipe increasing or decreasing at 3? Well, how do we determine that? Well, we need to find the rate of change of the water in the pipe at 3. Well, the rate of change in the water in the pipe ought to be R minus D. So we're looking for R of 3 minus D of 3. If that's positive, then it's increasing. If that's negative, then it's decreasing, right? Because this R is the rate of change that it enters, D is the rate of change that it drains. We want to know if the amount is increasing or decreasing. Should be the integrals of R and D. So the derivatives of that, R and D, is the rate of change. What does that come out to be? What's R of 3 minus D of 3? Negative 0.313632, which is less than 0. And so we would say the amount is decreasing. Everybody good there? Part C. We want to know at what time is the amount of water in the pipe at a minimum. Now they give us a closed interval, 0 to 8. So if they ask for a minimum on a closed interval, what do you need to check besides critical values? Endpoints. So we're going to need to figure out the amount of water at 0, the amount of water at 8, and the amount of water at any critical values. So critical values would be when the rate of change is equal to 0. So we want to figure out when does R minus D equal 0. And you just plug that into your calculator. You'll find that that is true when T is 0, which we were going to check anyway because it's an endpoint. And when T is 3.27165.8. And so we're also going to check T equals 8 because that's an endpoint. What is the amount of water in the drain pipe? The total water should be equal to the initial amount plus the integral from 0 to whatever T value we're testing of R minus D. Everybody good with that? Like the amount of water is the amount that we started with plus the amount that flows into it minus the amount that drains out of it. And the amounts that flow in and drain out are the integrals of the rate, just like we did in part A. So make yourself a little chart if you want. At 0, we said that there was already 30 in there, I believe. Right? And then we'll have to do 30 plus the integral from 0 to 3.27165.8 of R minus D. And then we'll have to do 30 plus the integral from 0 to 8 of R minus D. And get both those values. And looks like at 3.2 whatever, it was 27.964561. And at 8, it was 48.543686. They were asking us for a minimum. So they want to know at what time t were we at a minimum. So we were at a minimum at this t value. Good or no? Any questions or issues on that one? People in the Zoom, are you good? People here, are you good?
I'm good.
Anybody else there in the Zoom?
I'm also good.
Oh, good. 2 out of 14 people that aren't me in the Zoom are good. Great. All right, part D. The pipe can hold 50 feet of water before overflowing. When T is greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. We want to write, but we don't need to solve, an equation involving one or more integrals that gives the time, W, when the pipe will begin to overflow. So we need the water in the pipe to equal 50, right? So what are we going to do? We'll say 50 equals, and then it should just be, we can do this multiple different ways, really. One is we can start at 0, right? The other is we can start at 8, since we know how much water there was in the pipe at 8. True? Either one would be good. Might as well just start at 0. 30 plus the integral from 0 to, what was the variable they wanted us to use? W? Is that what it said? Yeah, time W. So from 0 to W of R of t minus d of t dt. And that ought to give us the value. And they gave us, let's see here, what did they give? 2 points for that. One for the full, one for just the integral part of it and one for the full equation. And they say you don't need to solve it, so you don't need to solve it. Everyone good there? You all feel okay about that? How do we feel about the rate questions and the graph questions in general? Austin, no? You don't know? Getting there? All right. Let's do, or yeah? One rate, one graph, yep. So for, yeah? Sure. For tomorrow, I didn't say anything about multiple choice tomorrow, right? Multiple choice again on Monday, is that what I said? Yeah. Okay, so for tomorrow, do this gravel one, I guess. And I don't really like this one. I guess just do the gravel one for tomorrow. If you want to do any others beyond that, you can. So we're going to do the first 3, the last 3 of the 2021 questions. Then we'll do this gravel one. Then we'll maybe look at one more graph one. Make sure you guys are good with both those before the quiz on Friday. Sound good? All right. And starting next week sometime, I'll start having chances for you guys to retake, like, because I'll have quiz 4 graded, and you guys, if you need to retake it, there'll be an opportunity to retake quiz 4 sometime next week. Cool. Anybody have any questions? You got a couple minutes, you could work on the gravel problem right now.